All right, so let's start. So thank you everybody for joining me today. As I said earlier, this is my first time doing it, where I am, you know, presenting some concepts for the cloud. But I thought it'll be a nice refresher for those who are familiar with cloud, and for those who are new to cloud, can learn a little bit about at least the basics. I'm not going to dive into any details in terms of how the cloud infrastructure works. For CISSP, you need to really understand just the concepts and terms and definitions and apply them to any question they present on the exam. So I'm not going to go very in detail, but if you have questions, there's always room for us to look at it and come up with answers or find answers for you. But for this discussion, it's very basic, very high level. So I want to kind of start off with what this discussion will look like for the next 60 minutes or so. It may go a little bit over 60 minutes, but I'm going to try and keep it under 60 minutes. So we're going to look at the concepts and some cloud basics, and we're also going to look at 5 questions that I found on all of these practice tests that I had. Mostly are from the official practice tests from CyBEX. So we're going to go through those just to kind of answer them and see if, just to get a familiarity with the questions on cloud. And of course, I'm going to open up the microphone. I guess anybody can then talk and have like a discussion. So again, that can go from anywhere between 15 minutes or more. So hello, a little bit about me. Just want to kind of tell you, you want to know who's talking to you, right, on the other side of the computer. And you hope it's not a robot or a bot. So I'm not a bot. I am a human being. I call myself accidentally an IT guy because I started, as my academic background is in control systems and computer engineering. So I'm not really I didn't start off with IT. I spent about 10 plus years in instrumentation and control systems. So it's a very hot topic today because all of these SCADA systems are called the distributed control systems. Manufacturing processes, controls those processes. All these systems are being now tied into different networks and data is being exchanged. So it's become a really hot topic. But I kind of did that back in the days. However, I still am in the same field because I still work for like a manufacturing company. So there's always some work related to that. But more and more people are now going towards more, operational technology where they're trying to secure the networks. So there's more focus on that, especially with all the threats and vulnerabilities these systems pose. So I just started maybe 5 years ago into network security and firewall configuration and for industrial systems. Of course, that comes with backup and recovery, and you want to be ready if there is an issue or disaster. You want to make sure your processes are running all the time. So there's always that backup and recovery and business continuity, which is part of it, associated with these critical systems. I also hold a CIDJ credential. I don't know if you are familiar with that. It's certified in dad jokes. So I make a lot of dad jokes. If you are familiar with that. If you have questions about that, we can do another session. Anyways, so going forward, so I want to tell you a little bit about my first certification. Everybody has their first certification, right? So you out of college, or you have some experience, or you go out and you take those first certification, you go through the exam. My first certification happens to be CISSP. So I kind of got busy in life or didn't find time or didn't manage my time well, or I didn't have enough sense to, actually go through certification. So I did not really pay so much attention to the industry. However, at this point of time, I did feel that I needed a something to validate my experience, and so I went for CISSP. I could have gone with other certifications. In fact, I'm looking at doing some Azure certifications, and it's just to so I can be current. So that's the whole deal. But so CISSP is my. I did pass it at the first attempt, but there's more to just passing it, which I'm sure you will understand as you go through these questions and concepts and people telling you to have a certain type of mindset. Very important to have a mindset that is of a like a risk advisor, or sometimes they'll tell you, hey, you need to have a mindset of like a manager. Um, it is true not just when you're answering the questions, but also when you are studying for the exam. Not many people pay attention to that. When you're trying to study a concept and you get really deep into the technical part of it, but it is very important to have the mindset of the risk advisor. So when you're studying, try to pick up cues and aspects of what an advisor would do if this particular system would be would have issues or problems. So this way it'll um, help you with the answering these questions in CISSP. So I want to congratulate everybody. Very important. I know this is you either may have attempted CISSP before, or you are here studying for it because you have not attempted it and you have an exam registered. But I want to congratulate everybody, because the reason why you're here is because you have the the reasoning and the motivation to get the CISSP, because you are a CISSP. Why I say that is because in order to again write the exam, you have to see yourself in the mirror and say, yes, he is or she is, or that CISSP. You are the certified information system security professional who's now going into maybe a meeting and then giving your advice or your thoughts on what the company should do to improve their security posture. So if you haven't thought about it already, think about it this way, that when you go into the Pearson VUE testing center, look at it as a company. Walking into a meeting, you're sitting down there and hey, you're ready to understand what the problem the company has, and here you are trying to give them the advice. So have that mindset. It definitely helped me when I answered my questions. By the way, I had 150 questions that I had to answer. A lot of people are better prepared or to answer these questions within 100 and they get out, but I was I was there till about 150 questions. Of course, that tells you something. Technically I may have a lot of incorrect answers, but then I managed to pass because I applied some of the rules that are constantly being talked about. Process of elimination, do best educated guess, and so on. So moving forward, let's get back to the cloud. Do all of this. So when you think of cloud, you think of a lot of different things, right? So there is I'm not going to read out every one of these here, but if you just think about cloud, it's self-service, right? So you can go in there and you can get what you want at your convenience. You don't have to wait for someone to do it for you. It's also easily available. It's always available, whether it's morning, afternoon, it does not matter. It's always available. At least you feel that it's secure, right? Most of the apps that you use, they provide you with whatever security that makes you feel that you are your data is being protected. um, there are other features such as, you can pay as you go, Netflix or Amazon, whatever you think about. So cloud has these great, and so I think everything is moving towards the cloud, including some of the things that we thought traditionally would be on premise is now being looked at in a different way because there's a lot of cost savings, and there you also get some sort of security that comes with it. And I want to clarify that just because you put everything in cloud doesn't mean it's secure, and we all know that. But it is easier to implement security when you have uh, things in place, controls in place, and you have. But there's so many different aspects of cloud. So I'm going to say, don't even look at this slide. This is too confusing. For CISSP, we need to look at a simpler um, classification of features. And so we go and refer the NIST standard document. There's actually a special publication that was put out by NIST, and it's the publication 800-145. If you try to download that PDF, the NIST publication, and read through it, that's all is enough for your CISSP. I honestly tell you, most of the questions come from that document. And I say it comes from that document, not necessarily, everything is from the document, but it's all the concepts and terms that are described in that document. So what is cloud computing? So cloud computing by NIST is a model for enabling ubiquitous, which means omnipresent. The word ubiquitous, by the way, if you haven't invested in a dictionary, which I did because I was having a lot of difficulty with English words, especially the ones that like this one, to really understand what it meant. So omnipresent, omnipresent, if you believe in God, it's God, right? It's omnipresent everywhere. Air is omnipresent, it's everywhere. So cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. And resources here in these networks, servers, storage, applications, services. Services like identity as a service. It could be disaster recovery as a service. It could be software as a service. I'm throwing out all these names. Don't get overwhelmed by these because NIST has categorized them into just 3 so that you don't have to really argue or discuss on what constitutes a proper classification. NIST has done all that work for us, and they have said, there are basically 3 types. We're going to look at that in a second, but there are basically 3 types. The software as a service, SaaS, platform as a service, PaaS or PaaS, and infrastructure as a service. So any of the other any other as a service offering should fall under these 3. So for CISSP, just think about these 3 services and nothing more than that. So I did have some examples. Convenient, easy to use, trouble-free, user-friendly, like a wallet. It's always with you. You can pull it out. You have your credit cards, debit card, cash. On demand, you get it when you need it. Like a friend. Hey, you can call him anytime and say, hey, I didn't understand that CISSP question. Can you help me out? Or hey, I need some cash. Whatever you call your friend for. On demand, shared pool, or multiple different types of resources. I kind of like to think about it like forest. This concept came to me after I saw the movie Avatar. They basically use the forest as a pool of resources. It gives them everything. So that's what I like to think about when I think about shared pool. So some things to kind of remember. Alright, so NIST, as I said, identified these 5 characteristics of cloud computing, and these are the 5 characteristics. Now if you kind of understand what these things mean, I think that'll be more than enough for the exam. So what does on-demand and self-service mean, right? A customer can provision conveniently the required, let's say, server time or storage. That's what in cloud computing on demand means, right? So if you're on demand, if you can get something on demand, a customer should be able to get any kind of server time. I'm not going to go too much details into server time, but if you want to look it up, you can. There's plenty of resources online. But what it basically means is if you were going to run a server for say a couple of hours to do your job, you should be able to do that and then shut down that server. Also, if you needed some extra, let's say to do some computer, one of the characteristics is being able to provide you on demand. Broad network access. What does this mean? So the system provides capabilities to be easily accessed through various network interfaces and devices like your phone, your laptop. So you should be able to access these. And I think about a good example would be like a Google search engine. I don't know if you remember this. Before the smartphones came out, Google search engine was available obviously on the computer, right? So you could go on your Netscape, I'm sorry, not Netscape, on your Firefox or Internet Explorer, and then you could search anything you want. But then there was in the US there was also a 411 like calling where you can call Google and you can actually talk to the person and they would give you some information. And it was actually provided by Google. Obviously that service went away, but I just think about that anyways. But they have grown since then obviously, and they have created multiple platforms for us including Android and so on. But broad network access, I think about an application like Google search engine because it's accessible on your phone, on your computer, in your car, also on your home speaker. So you can think about it like different network interfaces. uh, the next characteristic is resource pooling. What is this? And I kind of gave you an example of resource pooling was like a forest, right? So multiple resources are pooled to provide services to multiple customers in multi-tenant model. What is multi-tenant model? Multi-tenant is basically multiple customers that are using those resources, but they obviously are in the fence line. They can't see each other's data, but they're using the same resources, the underlying infrastructure. So that is a characteristic of the cloud. So you're able to have multiple customers. If I was the cloud service provider, which is CSP, then I can have 1,000 customers, but then I can have just couple of data centers, one in each geographical area, and then be serving them. They don't know how many customers I have, or what other customers is doing with their data, but then I'm able to serve each individual customer and provide them with any type of service level agreement that I have discussed or agreed upon. So that is the characteristics. It's able to do that. The cloud is able to do that. The next one is rapid elasticity. Elasticity, rubber band has an elasticity. So think about something that can expand and then contract, right? So something that can increase and decrease. So if you had like a restaurant, this is a good example. Why? Because restaurants, they run, most of them run 365 days, 365 days a year, right? So they are always open. However, on certain time of the year, let's say Christmas, Diwali, or any other festival that's like the most popular festival, people tend to take food out or order food. The demand increases, and the chef or the owner of the restaurant would have to add more resources for those particular times of the year. So cloud provides us with that type of elasticity. If our users go up, down, demand goes up for a certain service. Amazon would be a great example. During holiday seasons, shopping goes up. They have to spin up more servers so that their Amazon.com is available for billions of people. So that's rapid elasticity. So that's another characteristic of the cloud computing. And then the last one, so there are totally five, right? So one, two, three, four, five. So the last one is measured service. This is a little bit, what you need to understand about measured service is that something is being measured. It could be useful if you had a service level agreement where you're saying you have a 99.99% availability, or there's going to be just a 1% downtime, whatever. So something has to be measured. If you don't measure something, you won't be able to optimize it. So this is the concept here. So cloud computing is, you have to be able to measure it, and cloud computing provides you with that, because there's a lot of different ways you can measure. You can measure the cloud computing usage. You can see how many processors are being used, and how long have been, they're being used, how much storage is being consumed, how many servers are being spin up. All of these translate into numbers that can then be used to make more decisions, whether it's automated decision or whether it's manual decisions. But in this case, cloud provides you with automated decisions. So I think here, I think I have an example of billing or something like that. Yeah, so to think optimization and billing. So they automatically control services and optimize resources. So being able to automatically optimize based on performance indicators or demand. That's what is another characteristic of cloud. So 5 characteristics. Remember that these are the ones: the on-demand, broad network access, resource pooling, rapid elasticity, and measured service. So if that was all the characteristics of cloud, what are the modes of operation? Now, I was talking to you earlier that there are so many different types of as a service that people throw out. You go online and look for cloud as a service, or application as a service, or system as a service. I mean, you can basically come up with your own, a flower as a service. I don't know. There may be 1,000 of those. Now, for cloud computing, NIST has categorized just 3 services, and everything should be falling under these 3. So software as a service, I have an example here for you guys. It's the Salesforce. That's one of the applications that is quite popular. So software as a service, platform as a service, I think about Azure as the example, and infrastructure as a service, which I think about as AWS, and there's Google too, but I think more of AWS because it's kind of popular. But let's go in detail about these 3 different types of services, so you can really differentiate in the exam. So in the exam, they'll create a scenario and they'll ask you to select whether that particular scenario is a platform as a service or infrastructure as a service. And how do they do that? They actually describe what the customer is doing, or is intending to do, or should be doing, in order to provide availability, or provide integrity, or one of the confidentiality, one of the lines of the triad. So let's look at each a little bit closer. Let's see what the time. Okay, I think we're doing pretty good. So software as a service, this is a method of delivering software applications over the internet as per the demand and on a subscription basis. Okay, this is how I like to think about it, because anything that has a subscription, Netflix, that's a software as a service. Email, Office 365, that's an example of a software. So a software as a service company helps you host and manage the software application and underlying infrastructure, and handle any maintenance, software upgrades, patching, all of that. The SaaS company does it for you. So if you are a customer and you are signing up with a SaaS company, they will manage all of that for you. All you are responsible for is the data and access management. So Again, remember, I told you, just because you put everything in the cloud doesn't mean your responsibility is over, everything is secure. You still need to do everything that you were going to do if you were going to host that on premise. So that is software as a service definition. So for platform as a service, now between the software as a service and platform as a service is uh, both are actually software. If you really think about it, operating system is still a software, right? I mean, I get it. Some people call it runtime, middleware. There are different names, but they're kind of still kind of software. So it is a method that offers to provide an on-demand environment for developing, testing, delivering, and managing software applications. Which means basically, you get to install your own application on this platform and test it and run it, patch it. Basically, you're responsible for it, not the company that's providing you with the solution. What are they providing? So they are providing you the infrastructure, the underlying infrastructure, such as the servers, the storage, network, and as needed for whatever you're going to do with it. So some companies provide you more, some provide you less. Here we're not really arguing or trying to pinpoint what they are providing, but just understand that the application is your responsibility to set up, configure, make sure it's patched. It's your responsibility and not that of the platform as a service provider. So the next one we look at is the infrastructure as a service. So this is basically you are now looking at not just the end user who's using Office 365. You're also looking at maintaining the Exchange server. However, you're also now looking at installing believe like the virtual machines that the Exchange server runs on. Okay, I actually have another slide here which will kind of give you a good difference between these three and kind of make you understand. I'm using the example of the Exchange, so you will get a better understanding at that point. So let's we could go to the next slide. Let's see what I have here. What I have is a on-premise. Even in fact, on-premise is not part of the cloud models that we're going to talk about, but I just put it in there so it kind of gives you an idea as to what are the different components that you have to manage if it was you had everything on site or on premise. So you would have the physical building. So I have like these blocks on top of each other. So the bottommost block is a physical building. On top of it is a networking and cabling and all of that. And then on top of that is your server blade servers, storage and memory, and obviously on top of that would sit the operating system. Again, I'm not going to go detail into what type of system this is. It could be a virtualized environment or a not a virtualized environment, and there are different types of virtualized environment. I'm not going to go detail into that, but this is just a very high level. So on top of that operating system would then sit the application, and I was going to take the Microsoft Exchange as a good example because I think everybody's familiar with it. If you're not familiar with Exchange and haven't used Exchange, it's your email server that sits and basically does all the email functions, sending, receiving, and it does a lot more than that, but that's what Exchange is. And with an on-premise solution, you host it, you manage it, you have your internal guys running around and making sure that the servers are patched and there is sufficient storage, computing power that you have in order to your data and your daily operations. So that's basically explanation of on-premise. Platform as a service and software as a service. Now you can kind of notice that I flipped them. When I was in my previous slide, I had the software as a service, platform as a service, and infrastructure. Here I start off with IaaS because I thought it'll be kind of cool to see um, what uh, what kind of responsibility does the vendor, which is your cloud service provider, CSP, has versus you as a customer. So if you see on this, the green represents the vendor's responsibility, and I grayed out the customer responsibility. So anything that's in gray is customer, or in your case, whatever you're seeing, sometimes the colors may not come across. So with IaaS, majority of the responsibility is with the customer. So that's why you see the software, OS, processor, storage, and memory. And with networking, it's kind of like on a very thin line right now, because a lot of networking is also now virtual, and so it could be outsourced. I mean, it could be customer's responsibility depending on what kind of a product you're looking at. As we are very generic, I kind of highlighted that in green. But if you look at this, the only thing that's the CSP, in the case of infrastructure as a service, is responsible for is the physical building, to make sure there is electricity, power, redundancy, there is air conditioning, there are people maintaining the data centers, just whatever infrastructure wise that is required to support their their operation. So all they're responsible for, physical building and some networking, and I put firewall because that is the responsibility of the CSP, to make sure they provide you with either a VPN access to your infrastructure, your rented infrastructure. So it kind of comes under the CSP. So with the platform as a service, a lot of the responsibility goes on the vendor. However, the application is still your responsibility, and so that's what I have represented here. And with the software as a service, if you notice, all of it is the responsibility of the vendor. Again, when I say responsibility, it can be understood in many different ways, right? So who's responsible for what? There can be, when you are signing up with a service provider, a cloud service provider, you have many agreements. You have back and forth and see what they provide and what you need. Once you're settled with all that, you go in and start looking at their support, what kind of uptime they have. There's a lot of things that goes on before you even start using their services. And the responsibility of what, right? What are you responsible for? Keeping it up and running, or keeping it secure? They're two different things. Or making sure you can recover from a disaster. That's like a third thing. So there are so many different aspects of this. We're not going to go detail into that. However, just for you to understand that regardless of what you see on the slide, the customer is always responsible for security, right? So you can kind of say, hey, yeah, I have Office 365 for my so I've transferred my risk to the cloud service provider. However, you are still responsible for your email security. You want to make sure you are following the right guidelines, you are the regulations in your region. You're not sharing sensitive information, whatever that may be. That is still your responsibility. So you will see some questions like that where you may be asked whose responsibility it is, or the questions may be twisted, but always remember, security is still your responsibility. Now, until unless you have an agreement, which is a special agreement that tells that even the security of it, identity and access management and data, is the responsibility of the CSP, in that case it wouldn't be a solution that we are looking at. It will be something different. It will be something that is, think of an example, but it has to be specific, very customized. So for CISSP, this is what you need to remember. So if you have any questions about these, we can always discuss at the end of this session. So that was cloud models, right? I'm sorry, cloud. So all of this was, let me go back. Sorry. So all of these were basically modes of cloud services. So remember that this is their modes, okay? And now we're going to look at models. All right, so modes of operation and models, okay, they're two different things. This is again there to depending on a lot of different reasons, right? So one of the reasons may be you want to be able to be reliable, and you can use these different models to come up with, hey, who is ultimately responsible for data, or who is responsible for a certain application. So these models actually help in deciding that. So I'm going to go very briefly with these cloud models. They're fairly easy to understand, but if you have more questions about it, obviously we can take a look at it again. But so a cloud deployment model is defined according to where the infrastructure for the deployment resides and who has control over that infrastructure. Okay, so basically whether the vendor has the control or the customer has the control, and that's basically that decides what kind of controls need to be applied. All right, so for private cloud, so if you notice there's actually a community cloud inside a private cloud. Please don't misunderstand that. Even though I put it in there, just to give you an idea, there are really three types, right? So there's private cloud, community cloud, and public cloud. For CISSP, that's all you need to remember. So there's private cloud, community cloud, and public cloud. What is a private cloud? Of course, I have a hybrid there. We'll talk about that. The private cloud is typically an infrastructure used by a single organization, such an infrastructure may be managed by organization itself to support various user groups, or it could be managed by a service provider that takes care of it either on-site or off-site. I know it kind of got a little confusing there, but private cloud can be thought about as something that you host on-premise, and you have site somewhere, and then you're tying those two sites together, and that's your private cloud. Your employees on the road are able to access that maybe through a VPN, but you're maintaining it. Or you can decide to put all of that into a cloud service provider, and still your employees are still the ones who are utilizing that cloud, not somebody who's walking down the street, who's not an employee. It's only for employees. So think about private cloud as a very specific type of cloud computing that's implemented for an organization. A community cloud is a deployment model that supports multiple organizations sharing computer resources that are part of community. And there are some examples that I would like to give. So universities can come together and say, for research purposes, let's have a cloud computing setup where we'll utilize these resources for our data research or whatever research they're doing, and they need to use this computing power. So that would be kind of considered as community cloud. But community cloud can also be thought about your different departments in your own company, let's say HR, and wanted to set up a separate cloud, and it is for the use of your let's say employees, or maybe different department heads. So it's a separate cloud in the cloud, so you can have another cloud service under your private cloud. So that's what community cloud represents. Again, it could be just like as I said with a university or so on. Public cloud is basically, I think about it as the internet, right? So public cloud is for everybody to use, and Again, it's the name suggests it's the type of cloud deployment model that supports all users who want to make use of computing resources, such as hardware, CPU, memory, storage, or applications, software, such as database, but maybe on a subscription basis. Now that's a public cloud. Your email is your best example. Google Drive, Google has a public cloud and you're utilizing that. What's a hybrid cloud? So in hybrid cloud, an organization makes use of interconnected private and public cloud infrastructure. So this is a case where you're using the public cloud, and but then you have a certain area of your um, organization that requires a very confidential or something that needs to be separate from the public. You don't want it to be public. Only your employees should be able to access it. So something that can tie into the public cloud. So it's a hybrid. Now it could be any of these three or combination of these three. So that's why they just call it hybrid cloud. So for cloud models, all you have to remember is there are three main types, and obviously there's a hybrid, which is a combination of the three. So we're kind of closing towards the end of our discussion here or presentation. So what are the key points to remember about the responsibility? And I was telling you about the responsibility, who has the responsibility, and I've seen some questions that talk about this a lot. So I thought, why not just make it stand out, and so that way you can kind of focus on it. With software as a service, remember, it's the software, so like Salesforce or Office 365, it puts most of the responsibility on the cloud provider. So you can think about it like this. Let's say you are Office 365, you're sending and receiving emails through their email service, and suddenly your email stops. You are basically just going to pick up the phone and call them. So that's their responsibility. So most of the responsibility falls on them. Now, even though most of the responsibility falls on them, like I said, customer is still responsible for data and identity access management. So you are still responsible, if you are a customer, to make sure the right people have access to the right data at the right time. With platform as a service, customer is typically responsible for security of its applications, because now you have decided to host an application. So you took a service from a company that is providing with the platform to run that application. So you are responsible for it. You are responsible for patching, making sure that application is running. You are also responsible for data, obviously, and identity access management. So if you notice, I'm just adding more responsibility to the customer as we go from software as a service to platform as a service to infrastructure as a service. So with infrastructure as a service, customer typically is responsible for security of its application, data, IAM, and the operating system as well. So because with IaaS, you actually get to create your own virtual machines. It's the coolest part, right? So creating virtual machine, spinning up new virtual machines and basically deleting them. But you're responsible for it. Every time you run a virtual machine, you are paying for it, as well as you are responsible to protect it, patch it, and so on. So those are the kind of key points to remember in terms of responsibility. All right. So I know this is there's a lot to discuss in an hour. So I only put like the high level points, but I definitely encourage you guys to go in and read more, and then after this discussion, after you read some more, you may have more questions. We can probably do another session, but I would definitely like to have your questions so that we can kind of focus on that particular topic. Again, don't go too much detail into it. Like Adam Gordon from IT Pro TV says, it's just deep and a mile wide. Don't go a mile deep, and in a inch wide or whatever. So make sure you go high level. All right. So what did we kind of learn today or looked at today? So we did the different delivery models, the different types of software as a service, infrastructure as a service, and platform as a service. These are all delivery models. And then we looked at the deployment models, or the models and modes. I guess I should have said delivery modes on the top, and then deployment models. Anyway, so you have public, private, community, and hybrid. Essential characteristics of cloud. We discussed that in the beginning. Resource pooling, multi-tenant, multiple customers. It's on demand, self, a gas station or a petrol pump where you can go in and serve whenever you want. I can drive down at 1 o'clock in the night, and not in most countries, but in the US you can go and put gas in your tank. And broad network access. I talked about different interfaces that you can have access to that application. Rapid elasticity, speedy provisioning and deprovisioning, measured service, pay per use. You can actually have lot of cost savings because you're just doing pay per use on that. So before we go into the questions, do you guys have any questions? I can kind of take a small pause here. And anybody? Sure. So thank you again for everybody. I know we went a little, actually 20 minutes over our time. I knew I was going to go a little over, but anyways, thank you for everybody's time and patience. This is my first time doing it, so I would like to hear your feedback on how I can improve this for the next session. I plan to do another one, like a follow-up on the same topic, because I know we'll have more questions. And I didn't go into a lot of details this time, but if anybody is interested, please let me know a specific topic under cloud. We can discuss it. For CISSP, again, I'm not going to go into too much detail, but if there is a question, we can always pull that out and discuss.